Okie doke, so in this, the third video, we're going to be looking at an absolute value function. You can tell it's absolute value because of the absolute value bars right there. Notice that the only other thing happening here is we're adding 2 and subtracting 3. Those are both arithmetic operations. That means that this is going to look something like an absolute value function. Now, in order to do the graph, we're going to do the same thing that we did before. We're just going to add a little bit. We're going to put some x values in and get some y values out, and we'll look at our picture. So let's start with -2. So I put -2 in, and I get -2 for x, and so I go -2 plus 2 minus 3. And -2 plus 2 is 0, so I got 0 minus 3, which will give me a -3. So I'll put -2, -3 on my picture. Okay, and then I go, and let's go x equals -1. So I go -1 plus 2 minus 3. And so -1 plus 2, -1 plus 2 is 1. The absolute value of 1 is 1. And 1 minus 3 equals -2. And so I put that down. I go to -1, -2. Doop. Alright, and so then let's try 0. And so I put in 0. 0 plus 2 minus 3. 0 plus 2 is 2. Minus 3 gives me -1. So there we go. Now, you may notice that I don't see any of the vertex, right? This is supposed to have a vertex somewhere. Now, the vertex happens because at some point I'm going to start taking absolute values of negative numbers, and it's going to be giving the same thing as positive. And what I noticed is I got 0, 1, and 2, and my numbers inside my absolute value are actually getting more and more positive as I go farther. So what I'm going to do is, instead of putting in 1 and 2, because if I put in 1, it's going to just go further this way. It's going to give me a bigger positive number. What I'm going to do is I'm going to actually go more negative. I'm going to go back the other direction. And so I'm going to put -3 in for x. Again, the reason why I'm choosing this is because I see that it went from 0 to 1 to 2 inside the absolute value, and those numbers are just going to get bigger and bigger, which means this is just going to continue. So let's try something a little bit smaller. We're going to put in -3. So I'm going to go with the absolute value of -3 plus 2 minus 3. And -3 plus 2 is negative. Oh, there's my negative number. And the absolute value of -1 is 1. And I go 1 minus 3, which is -2. And so then I go -2. So there's -1, 2, 3, -2. And bloop, there it goes. Alright, and so now you can see there's my vertex. I just found it. And so we'll go ahead and we'll put in one more point on the other side. -4. And we'll put in -4 plus 2 minus 3. -4 plus 2 is -2. And the absolute value of -2 is 2 minus 3 equals -1. So I got -1. Alright. Now, there is a little bit extra space here in the table. So if you had put in 1 and 2, that's fine. Just recognize, okay, everything's not working. I got to find that vertex, so check a little bit to one side or the other. We'll learn a little bit more later about how to deal with that and how to find that center point first. But for now, let's just deal with what we got. Okay, so now we have our graph. We can go ahead and draw. And then we do the other side. Oh, no, don't do that. Okay, there we go. Other side. Boop. Now, our shape is, of course, the V shape. When you make a V, please make it look like a V. Don't do a V like this, because I have no idea if that's a V or a U. V shape. Okay, domain. The domain are the x values. So note that it goes to the right forever and ever, and it goes to the left forever and ever. That means that the x is all real numbers. Okay? The range is the y values. So yes, it does go up and up forever and ever, but it doesn't actually go down forever and ever. It actually stops here at -3. So -3 is the lowest it can be, and then x needs to be bigger than that. X needs to be bigger or equal, because it can equal -3, right? Oh, sorry, no, not x. I'm doing range. This is y. Go away. So y is greater than or equal to -3. You could do the infinity as well, if you wanted to say it can go up to infinity, but you don't need to. So y is bigger than or equal to -3. X-intercepts, note that there are 2 of them. There they are. I got one x-intercept at x equals 1, so that would be 1, 0. And the other x-intercept is down here at -5, so that would be -5, 0. Alright, the y-intercept. The y-intercept is -1, so 0, -1, because the x value there is -1. The name of the parent function is the absolute value, or the modulus. The equation of the parent function is just y equals absolute value of x. That's as simple as it gets, folks. And the special features. Remember, the absolute value has the same special features as the quadratic. It's got a vertex, and it's got an axis of symmetry. Okay, so the vertex is this lower point right here, so -2, 1, 2, 3, -3. So there you go, -2, comma -3. And remember, the axis of symmetry goes straight through the middle, which always has to go through the vertex. And so you note that it goes through x -2 right there, and also the x value of the vertex is also -2, so we say x equals -2. And so that's our axis of symmetry right there. And therefore, we've completed everything for absolute value. All right, so good luck.